Good morning, students. I hope you're all doing well. Our topic for this morning is simplifying simple expressions. So our learning objective is to be able to simplify expressions using basic arithmetic operations. So we'll be looking at addition, subtraction, multiplication, and division. For your starter this morning, you have been given 8 questions to complete. Please pause the video, spend no more than 10 minutes completing the questions, resume the video, and check your answers. Here are your answers. Please pause the video again, mark your work, then resume the video to move on to the next slide. Our first task is to simplify expressions doing addition and subtraction. In the red box, our first example has a plus a minus a plus a. So we'll do it in stages. Each a represents 1a. So we have 1a plus 1a, which gives us 2 a's. Then we need to subtract 1a from that. So we're left with 1a. Then we need to add one more a, and so our answer is going to be 2a. In the yellow box, we are tasked to work out 4b plus 3b minus b. So all we need to do is take them in stages. So 4b's plus 3b's would be 7b, and then we need to subtract 1b from that. So we're left with 6b. In the green box, we need to work out 3c minus 4c plus 2c. So in stages, we'll start from our left. 3c minus 4c would give us a minus 1c. But then we need to add 2c to that. So minus 1c plus 2c would give us 1c. And on the blue box, we have d minus 6d plus 3d. And as I said, d standing on its own would be 1d. So 1d minus 6d, 1 minus 6 is minus 5d. And now we need to add 3 d's to that. So minus 5d plus 3d is going to give us minus 5 plus 3, which is minus 2d. Now pause your video and try these 4 questions. Once you're finished, resume the video to check your answers. Spend no more than 5 minutes doing this task. Go. For the first box, the red box, the answer is 4a, because we have 1a plus 1a, 2 a's, add one more a, 3 a's, another a, 4 a's. So the answer for that is 4a. For the yellow box, our answer is 6b. We're adding 2 b's plus 3 b's to get 5 b's, and adding one more b, and that gives us 6b. In the green box, we need to work out 3c plus c minus 2c. So for the first two, 3c plus 1c is 4c, but we need to subtract 2 c's from that. So 4c minus 2c is going to give us 2 c's. And the final one, 1a minus 6a will give us minus 5a. We need to add 2a to that, so minus 5a plus 2a is minus 5 plus 2, which gives us a minus 3a. For this task, we have different letters in our terms, and so we are going to use the process of collecting like terms. So whenever we're adding and subtracting for simplifying expressions, we only can combine like terms. And so for the red box, what we need to do is look at what the different terms are, the names, and then we can combine them. So we have 1a here, we have 1a here. We need to add these two together because they're both a. So 1a plus 1a will give us 2a's. We're only left with b, which is a positive b, so therefore it becomes just plus 1b. In our next example, in the yellow box, we have again different names on our terms. We have a's and we have b's, and so we can combine the a's. Normally when calculating or simplifying expressions, we keep the letters in alphabetical order. It's not mandatory, but it just helps us to go through nicely. So we're going to start with the a's, and I have 2a minus 1a. So 2 minus 1 gives me 1a. Then we have the b's. So we have a positive 3b plus 3b. We need to add 1b to that. So we end up with 4 b's. So our answer is 1a plus 4b, or instead of saying 1a, we can just say a plus 4b. For the third example, in the green box, again, we have different letters, and so we can only combine the like ones. So we have C's and we have D's. So starting with the C's, we have 1C and minus 1C. So 1C minus 1C is 0C. So we do not need to write that one down. Then we move on to the D's, and we have a positive 2D, so plus 2D, and then we also have a positive 3D, which is plus 3D. So 2D's plus 3D's will give us 5D's. And that's our answer for the green box. Final example on the blue box, we have A's and B's. So again, we'll start with the A's. We have 2 A's, which is a positive 2A, and we need to subtract 3 A's. So it is 2A minus 3A. So 2 minus 3 is minus 1. So we have minus 1A. Then we need to work out our B's. So we have plus 1B, and we need to subtract 2b's. So it's 1b minus 2b. 1 minus 2 is minus 1. So we have a minus 1b. So our answer therefore is minus 1a minus 1b, or simply minus a minus b. Now pause the video again, try these 4 questions, spend no more than 5 minutes, no more than 5 minutes, resume the video to check your answers. Let's check. For the red box, we have A's and B's. So let's go with the A's first. We have 2 A's plus 1A, which gives us 3 A's. And we need to add 1B to that. There is no other B there, so we just put plus 1B. So our answer is 3A plus B, or 3A plus 1B. For the yellow box, we have A's and B's again, so we'll work with the A's first. So we have 1A, and we need to subtract 1A. So 1A minus 1A will give us 0A. Don't need to write that one down. Then we work on the B's, plus 3B plus 1B. So it's 3B plus 1B, which gives us 4 B's. So our answer is 4B. On the green box, let's work on the C's, as we have C's and D's. So we have 1C and 1C. This is a positive 1C plus 1C, and we need to add 1C to that. So 1C plus 1C gives us 2 C's. Then we work on the D's, a plus 2D, a positive 2D, and we need to subtract 3D. So it is 2D minus 3D. 2 minus 3 is minus 1. So we get minus 1D. Our answer is 2C minus 1D. And our final one is 1A, and we need to subtract 3 A's. So 1A minus 3A, 1 minus 3 is minus 2A. Then we will work on our B's. So 2B minus 2B, so positive 2B minus 2B, 0B. So we don't need to write that. So our final answer is minus 2A. Let's look at these examples where we have powers in our terms. Now, in the first one, we have a squared, and there's another a squared on this side. Now, we have 1a squared here. So the name of the terms are a squared, and then the coefficient or the number in front will tell you how many of them we have. So we have 2a squared plus 1a squared, which should give us 3a squared. Then we work on the b's. So we have a minus 3b and plus 2b. So minus 3b plus 2b, which is a minus 3 plus 2. Minus 3 plus 2 gives us minus 1. So we get 1 or minus 1b, or just minus b. So our answer is 3a squared minus b. In our second example, we have a squared again. We also have a and we have b. Now, a squared is a totally different name from a, so those cannot be combined. So we have to be careful that we use the same names when we are adding and subtracting to simplify our expressions. So it is therefore 2a squared plus 1a squared. And so that gives us 3a squared. Then we have a only, so it's minus 3a, no other a's in the expression, so we write back or minus 3a. Then we have our b, and it's a positive 2b plus 2b. There are no other b's in the expression, so we write back plus 2b. So our answer is 3a squared minus 3a plus 2b. Our final example here, we have a squared, we have b, we have ab, and we also have another set of b's. And so we will collect the like terms. So the only a squared we have is this one that I have circled. And so we write back to a squared. Then we have b's, a minus 3b and a plus 2b. So minus 3b plus 2b is minus 3 plus 2. Minus 3 plus 2 is a minus 1, so we end up with minus 1b. And our final term to take care of is 1ab. So the name is ab and we have one of it, so we just write back plus 1ab. So here's our answer, 2a squared minus b, which is a minus 1b, plus ab. Sometimes they might combine the algebra with geometry. So we're going to look at these two examples and see how we can write expressions or simplify expressions for the shape. Now, the first example we have here, it says shown is a pentagon, and the task we're going to undertake is to write an expression for the perimeter of this pentagon. Now, for a pentagon, if we're going to find the perimeter of any shape, rather, we add all the sides. We have 5 sides on this pentagon, so all we need to do is add the 5 sides. So I've started with x and then completed with y. So I have 1x, which is noted here, 2x, which I add to that, another x, which I add to that, and a y here, which is added, and also another y. Now, once I've written this out, I can now combine the like terms, and I have some x's, so we have 1x plus 2x gives us 3x, and then add one more x to get 4x. Then we combine the y's, which is 1y plus 1y, which gives us plus 2y's. And so our answer is 4x plus 2y, and that's an expression for the perimeter of that pentagon. We don't know the exact values of x or the exact value of y, and so we can only leave it as an expression in terms of x and y. Let us look at the next example with a triangle. It says it's an equilateral triangle. And so we know for an equilateral triangle, all three sides have the same length. So we therefore mean that this length is 2x plus y, and also this length is 2x plus y. And all we need to do, if we're looking at finding the perimeter, which is what we're going to undertake now, we just need to add all three sides. So I've written them here. All three sides written out in three different colors. All we need to do is combine the like terms. So we have 2x plus 2x to get 4x plus 2x to get 6x. Then we have 1y plus 1y plus 1y, so we end up with a total of 3y's. And that is the expression for the perimeter of the triangle. Let's look at this final example where algebra and geometry are combined. So here we have a rectangle, and our task now is to write an expression that represents the perimeter of the rectangle. So as we know, the opposite sides of our rectangle have the same length. So it would mean that this side is going to be x plus 3. And the horizontal length, which is opposite to 2x plus 7, will also be 2x plus 7. Now that we know all the four lengths, then we just need to add them together. So I've written them out. We have 2x plus 7 plus x plus 3 plus 2x plus 7 plus x plus 3. And all we need to do now is combine the like terms. So we will combine the x's, 2x plus 1x, that makes 3x's, add 2 more to get 5x's, and add 1 more x to get 6x's. Then we will combine the numbers. So we have plus 7 plus 3, which gives us 10, plus 7 again, which gives us 17, and plus 3 to that gives us 20. So the perimeter of this rectangle is 6x plus 20. For your independent task, I would like you to go to show my homework. So you'll pause this video here, go to show my homework, follow the instructions for task 1, spending 20 minutes to complete the task. Then you will mark and resume this video to move on to the next slide. Here we're going to simplify expressions using multiplication. So our first example, we have 3 times y which gives us an answer of 3y. We have 3 lots of y, so it's y and plus y plus y. 3 lots of y's would give us 3y. Our next example, 5 times 3w, so we have 5 lots of 3w. So our answer for that, 5 times 3, we multiply those to get 15, so we have 15w. Our next example, we have 4 times 2 times y, so we'd multiply our numbers, which is 4 times 2, that gives us 8, and then we just write next to it y, because we would have 8 lots of y's. So our answer to that is 8y. Our next example, we have 3a times c. So we have to multiply 3a by c, which would give us 3ac. Our final example on this slide is 2a times 3y. So we would multiply our numbers, 2 times 3 to give us 6, and then a times y is ay. So we end up with 6ay. On this slide, we are going to continue simplifying expressions from multiplication or by multiplication. So our first example is a squared times a. So now we're including powers. I will break down the powers to simpler terms to help us to build an understanding of how it works. For first example, our a squared is represented by a times a. Then our final a is added to the end of that. Now we have 3 a's being multiplied, so we have a being multiplied by itself 3 times, and that would mean we are cubing a. So a times a times a is a cube. For the second example, we have 2t squared times t, and again I will break down t squared. So we have 2t squared, which is represented by 2 times t, and then our final t in the question is also indicated here. As you can see, we have 3 t's being multiplied, so t is being multiplied by itself 3 times. So we have 2 times t cubed. In our next example, we have 3p squared times 2p. And so what we will do is we'll put the numbers together as it's all multiplication. Does not matter the order it's written in. It does not change the question. And so I am going to rearrange the question to help us understand or build our concept. And so we would have 3 times 2 written here. Then p squared is indicated p times p, and then our final p here is indicated here. As we can see, we have 3 p's again being multiplied, and so we would get 3 times 2, 6. Then p times p times p would be p cubed, and this is how we would write our answer, 6p cubed. Final example on this slide, again we are going to break down and reorganize to understand what we need to do. And so we would have 7 multiplied by 4, then our a cubed here is represented by a times a times a, and our a cubed here will be represented by a times a. So now we have 6 a's being multiplied together. So a is being multiplied by itself 6 times. So we call that a to the power of 6. So we have 7 times 4, which is 28, and a times a times a times a times a times a gives us a to the power of 6. So our final answer is 28a to the power of 6. Here are a few more examples of simplifying expression using multiplication. And so for the first example, we have ay times ay. So we're going to put the a's next to each other, which gives us a times a. And we're going to put our y's together, which gives us y times y. A times a gives us a squared, y times y gives us y squared, so our final answer is a squared, y squared. We do not need any multiplication signs for that final answer. In our next example, we have 4ab times 2ab, and so we put our numbers together. 4 times 2 is 8, then a times a next to each other, and b times b next to each other. So we end up with 4 times 2, 8, a times a squared, and b times b squared. So our final answer is 8a squared, b squared. And our final example on this slide is to multiply 2ad squared e times a cubed c. And so for this solution, we would have only 2 in our question. So no number to be multiplied by besides 1. So it's just 2 times 1. It's 2. We have 1a here. Then we'd have 3 a's here. That would multiply with that a. So we get a to the power of 4, if you should write it out. Then we looked at our c. We only had 1 c in the question to be multiplied. So here we have 1 c. Then we looked at our d. We only had d squared, which is d squared. And then we have e, which is 1e. So when multiplied, we would get 2a to the power of 4 c d squared e. Our final set of examples on simplifying expressions using multiplication will be a combination of our simplifying expressions with geometry. And so for these 3 shapes, we are going to find the area. The area of a rectangle, as we know, is found by multiplying the length times the width, or base times the height. So in the first example, our length is 8a, or width is 3c. So we only need to multiply them. So we would get 8a times 3c. So we multiply 8 times 3, which is 24, then a times c, which is ac. So our final answer is 24ac. For our next example, again, we are finding the area of a rectangle. The length is 9w, the width is 2w, and so we just multiply. So 9w times 2w, we multiply our numbers. 9 times 2, 18, and w times w would be w squared, as we're multiplying w by itself. So our final answer is 18w squared. Now for the triangle, the formula for working out the area of a triangle is base times height divided by 2. So first, I would multiply the base and the height, and the base is 6m and the height 2p. So base times height will be 12 mp. But then I would need to divide by 2, as the formula says base times height divided by 2. When multiplied when I've multiplied base times height, I got 12 MP. So this 12 MP needs to now be divided by 2 to get 6 MP. And that is the area of the triangle in this example. Now, go to show my homework, follow the instructions for the task, and spend 20 minutes completing the task. Pause the video here, spend your 20 minutes, mark your work, then come back to the video for the final segment of the lesson. Our final task or activity to complete is simplifying expressions using division. In our first example, we have 12x divided by 2. So we have 12x's and we need to split that into 2 equal parts. And so all we need to do is divide 12 by 2 and we will get 6x's. Then our next example, 9y divided by 3. And so we need to divide 9y into 3 equal parts. And so we do 9 divided by 3 is 3. So our answer is going to be 3y. Now, in our next example, we have 32abc divided by ac. And so what we would do is divide 32 by 8, dividing our numbers, and we get 4. Then when we divide a by a, that gives us 1. When we divide c by c, that gives us 1. And then b is not being divided. And so what we would be left with is that 4b. To make it clearer, I've written it out as a fraction to show you what actually takes place. And so I have written 32abc out. On top, 32 times a times b times c. And then on the denominator, I have expanded or I've broken it down, the AC as 8 times A times C. And so we will divide the 32 by 8 to get 4. A divided by A would give us 1. And C divided by C will also give us 1. There's no B in the denominator to divide this B, so it remains the same. So we're really left with 4 from this division here, 32 divided by 8, and 1b. So it's 4 times b, which is 4b. In the next example, we have 16c squared divided by 4c. And so we divide 16 by 4 to get 4, and c squared divided by c to get c. To make it simpler, for us to understand what takes place, we do the same as previously done. We divide 16 by 4, so I've written it as a fraction. I have expanded 16c squared to write out 16 times c, and on the denominator 4 times c. So the 16 divided by 4 will give us 4. C divided by c, where it's crossed out, gives us 1. And then we're left with a single c on top. And so 16 divided by 4 is 4 times the c that's left, gives us 4c. Now in these examples, we're going to use the same approach. It's already written as a fraction, the division. As we know, the line means we divide. And so I have written out 14c as 14 times c, and we need to divide that by 2. So the 14 is divided by the 2 to give us 7. The c will not be divided by anything, so it is placed next to 7 because this here gives us 7. 14 divided by 2, 7. So it's 7 times c gives us 7c. Next one, we have m multiplied by w from the numerator, and then m on its own in the denominator. The m will divide the m to give 1. The w will not be divided as there is no w in the denominator. So we end up with 1 times w to give us w. In our next example, I've broken down 30EF again on the numerator to get 30 times E times F. Under the denominator, we have 6 times E times F. We need to divide 30 by 6 to get 5. Then E divides E to give us 1. E and F divided by F gives us 1. And so 30 divided by 6 is 5, and then 5 times 1 will give us 5. On our next example, g squared divided by g. On the top, the numerator, we've written out g times g, and on the denominator, we have g. And so g divides g to give us 1, and then another g remains, so it's 1 multiplied by g to give us g. And the final example here, I've expanded, or I have broken down 35c cubed to 35 times c times c times c, and on the denominator 7 times c. Now we have to divide 35 by 7 to get 5. The c divides c to get 1, another c divides c to give 1 again, so we're left with a single c. So 35 divided by 7 is 5. So it's 5 times 1 times 1 times c, which gives us 5c. Now for your final activity, go to show my homework, follow the instructions for the task, spend 20 minutes completing this task, then mark. Once you have completed this PowerPoint, and you have marked your work, take a picture of your work, upload it to show my homework so I can see how you've done and give you some feedback. Also, at any point during the lesson where you feel stuck and need some assistance, please send a message through show my homework or an email. All the details for this will also be added to show my homework. Have a lovely day.